SwayamPrabha. Digital India. Educated India.
Hello and welcome to the course Industrial Robotics Theories for Implementation. In today's class, we'll discuss about industrial robots. In general, what is robot? So, what is a robot and what are industrial robots? How it is different from any other robots that you see? Timeline for the development of industrial robot we'll discuss. How it has evolved over the years. And we'll also see different applications of industrial robot. So yes, let's start. So what is a robot? Robot, there are many definitions that is existing over internet and various textbooks, but this is one of the most common one, which is a superset of all those definitions that I found. So it says a robot is an automatically operated machine that replaces human effort with or without any resemblance to human. Not like star movies that you see, it looks very much like human and they are Superman like, and they have too much of capability. Industrial robots are not like that, right? They are very much limited in their function, but they are made to do some specific task and they can do it every now and then, frequently and round the clock 24/7, right? So this is a further subset of the definition. They are usually programmable through a computer and can carry out a complex series of tasks automatically. Once they are programmed for any complex series of tasks that you will also see in the application videos that I'll show you now, right? It can perform very intricate tasks, we'll see. And then once it is programmed, it can repeatedly keep on doing it throughout each and every car that comes on the assembly line or any other thing, right? So industrial robots are used for manufacturing in the industry and are capable of movement on 3 or more axes. We'll talk about axes very much in detail while we'll be discussing kinematics in this course, right? So with all the attachments to the end effector is something that is right at the end tip of the arm, which is there, that holds the tool. So that tool can be a welding tool, that tool can be a gluing tool, polishing, buffing, grinding, anything like that. So with that end effector attached to the robot, it has a potential to do all sorts of dirty tasks, dull tasks, dangerous, difficult, or a dear task. I'll tell you, dull task is something like you have to keep on doing it whole day, right? You cannot, a regular person who is not trained to do it will take a break quite a lot of time in between, because they cannot do it, right? So that is the problem with this type of task. It is very much monotonous in that sense. Dirty task like cleaning a garbage tank, right? So doing that task in a manual way is a very dirty task. It is sometimes hazardous also. So that is a dirty task, and sometimes it is dangerous task. Let's say you have to do some navigation in a area which is radioactive zone. You have to find out, let's say, radioactivity in different parts of that region. So that is very dangerous, right? You are exposed to radioactivity in that region. So that is one of the dangerous tasks. There are many such which are there in the industry, within the shop floor also, right? And sometimes the jobs are very, very difficult, like material handling, you see. It is sometimes very, very heavy also. It goes up to a ton that is to be displaced every now and then. So that is a difficult task. And there is a special task which is a dear task, right? A dear task is a task which we want it to be done by the robot. Why? Because we want to do it very, very precisely, irrespective of the cost, whether it is dull, dirty, dangerous or difficult or not, we want to do it by a robot, because we want to do it very, very precisely every time, and it may be a very expensive thing, right? If you do something wrong with that, a huge amount of money is at stake and that can go haywire, right? So yes, these are some of the tasks in which industrial robots are applied. Okay, so here in this figure you see this is a huge payload capacity robot. It is one of the highest in its capacity. It is Fanuc M2000IA robot with a payload of something around 2300 kgs, right? And repeatability is as good as 0.18 mm. We'll talk about that repeatability, how it is defined and all in further modules of this course also. The maximum reach is something around 3.7 meters here. Okay, so this is one of the biggest one of its kind. This is an arm, right? So yes, we'll now talk about the timeline, how the industrial robot has evolved over the years, right? The first industrial robot is a Unimate. Unimate robot is the name given to that robot. This was a typical 4 degree of freedom robot, where it has a workspace which is very much like a spherical workspace till the tip before the last end effector, right? So it can do some sort of roll, right? It has one angle like this and it can rotate like this, right? 2 rotation axes and one of them was prismatic, so that can increase the radius of this sphere, right? And at the end there was one gripper which can do this motion, right? Pitch motion rather. Okay, so that is one of the oldest robot which was evolved, and then that took over industry and later on to various other purposes also. So this was invented in 1954 by an American engineer known as George Dayal, right? He invented this, and later on the development of Unimation Inc. Corporation, basically they took over this robot. They started making it commercially. It was founded by American engineer Joseph Angelberger in 1956, who started making it commercial, and first prototype was introduced in 1959 at General Motors Corporation at its die casting factory in Taunton, New Jersey. It was a die casting factory where it was first used. Later on, the world's first production line means you have a good number of robots which are there in a single assembly line, and each robot has a specific task to do, and that was implemented first time in General Motor factory in 1961 by Condac Corporation. It was an acquisition of Unimation Inc. So yes, these are the pictures of that assembly line and to these great men, right? So yes, now we'll see some of the application of industrial robot. So here this is one of the very commonly used industrial robot, which is known as arc welding robot, right? This is one of the most demanding tasks in the industry, and the robots are applied to do operation very often, and the one which you are seeing here is an arc welding operation. Here the robot end effector is mounted with a MIG welding tool, where the robot wire is fed automatically at a constant rate, right? You see such a nice outcome. The welding path is taught manually and can be controlled automatically using sensor inputs and a predefined geometry. See yes. This is a spot welding application, in which yet another very common in the industry where robots are used. Here the robot is mounted with a spot welding gun. In this case the object is mounted and the robot is taught all around to go and do spot welding operation. It can be otherwise also, when the electrode is stationary and the object is moving, right? This is a very common operation. This is known as a gluing operation, where you see a constant, this feed is given by the gluing extruder and the part moves all around, and that path is well taught sometimes, and sometimes it is done with the sensors. The geometry and the direction, everything is pre-taught. Now you see those parts are getting assembled by the robot, from one side after gluing. So that is a adhesive sealant that was put, and both the sides you see the covers are being put by two different huge robots. And there is yet another robot which puts the top assembly from the top. Right? That is a car which is getting built. It's a body shop, car body shop. Right? This is the assembly line. When you see spot welding, gluing task, assembling task, various other tasks are being done by multiple number of robots. You see one by one, and see hundreds of them are there in a single assembly line. Right? Quite interesting, and it keeps on doing it whole day long, right? So each robot has a pre-assigned task programmed to do it. See, this is a regular car dashboard, and yes, it is picked up from here, and then this robot is going. It is a KUKA robot. I think it is a Mercedes robot, Mercedes car. Yes, see, it just puts in just like a human, and gracefully it puts to a very good precision to its place, and will gradually leave it, come out just like without avoiding all the collision, and it will come out. It is programmed manually, sometimes using sensors. Again, a similar front glass of a car is being placed. Yes, again a similar gluing operation is being done here. You see, it is put to the car front. Yes, it is so nicely placed and accurately placed. And it another car will come, it will pick up another thing. Yes, this is a task which is a grinding task, which is again very common in the industry. Different tools are loaded in top of the robot in the front end of it, right, at the end effector, and each one perform its own task. Again, a different tool of different size, different abrasive size also maybe. So that is now inserted to a different location, it does the grinding task. In this type of robot, normally it is fitted also with a force sensor. It can feel the forces, right, so that it can have a constant force all over and do uniform grinding on polishing operations. So this is the type of deburring, and finally polishing will be done. So each process requires a different tool to be fitted at top of the robot, and each one does its own job. Finally you get to see a uniform finished thing, right? Yes, see, so nicely it is doing, just like human, because it is taught by human. See, so nicely looking uniform surface finish. Yeah, this is one of the most wonderful tasks you will see, you know. You see a silencer probably, or sometimes rack tube. So it is being cut by laser. So laser cutting is a very good operation that is done, because it is hazardous also. Humans cannot go inside to that chamber where laser is in operation. Powerful lasers are there. It is precisely cutting the task, see, uniformly orienting all over the tube, and it is cutting a profile, not just a circular shape, right? Looks like a silencer of a car maybe. Yes. Another similar part which is very profiley in this kind. It nicely orients and cuts, so every time the cutting angle is maintained, because the CAD is inserted to the geometry of that simulation tool, and finally offline programming is done, and that is fed to the robot, so which can be assembled later on like this. This is another very common, and it's a hazardous task also. This is painting robot. Different robots works just like human. You see, these are mirrored robot. It looks like a mirrored robot. From both the sides it is uniformly painting. One of the robot is just holding from the top, right? One of the robot is just holding from the top. It will gradually close it also, right? And some of the robots are opening the door, and still painting is being done by the robot, right? See, it can orient so nicely, no? All the sides it is doing so gradually and nicely without hitting anything. You see, robot itself is also shielded well, so that paint should not destroy the electronics which are there in the robot. This is a material handling task. You see, huge metals are picked up by the robot from different places. An n number of robots are there in a single workspace. They are arranging them, they are putting it from one place to the other. Each robot has a pre-assigned task which is programmed beforehand. See, one of them is hanging on top of a moving conveyor. See how many numbers of robots are there in a single workspace. From the top you can see it very clearly, different robots are doing different jobs. This is heavy material handling. This is one of the tasks where the robot is doing some PCB, pre-assembled PCB assembly to a system maybe, right. So, each electromechanical part is placed one by one and they are put to top of the PCB, and finally they will create a electromechanical assembly, right. Electronic industry has a specific requirement of precise robot, when sometimes you don't need to roll and pitch, you just need to pick it up and place it at a place, right. So, it has a different gripper. One of them will hold the chip, other one will hold something else. So, same robot can have different tools at its end. Now, you see this operation is in particular known as a pelletizing operation in the industry, where various objects of similar kind are stacked together in a carton, which can be placed on a conveyor, finally it can be loaded onto a truck and that is dispatched. So, this is a very, very common task in food and beverage industry like that, right. You see again similar multiple robots are handling similar packets and they are putting on the conveyor. One of them is taking out of the conveyor and putting it onto a different container, that is further carried out by a different industrial automation system. So, precise locating this carton in front of the robot is done by automation system, which has various other sensors which are integrated to the robot to well give it a feedback that yes, carton has now arrived here, now you have to pick it up, now you have to place it. See, yes. Now you will see a different kind of operation. It's a very long time it was a manual task. This is known as a machine tending operation. You see, this robot is now taking up a finished part which is machined already by the CNC machine, and it is placing a raw part inside, taking out the machine component from inside. So, whole of the day it will keep on doing that and machine will keep on. So, machine and robot is talking to each other. Yes, I have finished my task, now you start your job, right. It will press the button, it will come back and put it in front of the human, which may further do something with it. So, this is the finished part which it has kept outside. Now, it will pick up another raw material and ready to put it inside the machine, right. So, the cycle goes on. This is very dirty task. As I have just talked about this, it is a dirty task, sometimes hazardous also. It is garbage segregation. This is off the industry most of the time. So, industrial robots are not just used in industry, because it is a very versatile robot which can be programmed to do various other tasks. So, it is used off the industry also like this. This is garbage segregation, right. It includes a lot of intelligence also. This is a very, very special task when a robot is doing hair transplant, assisting doctors to do hair transplantation, right. They work with the doctor. It is a special kind of robot nowadays which is known as a cobot, right. So, doctor can precisely prepare a cartridge with all roots of your hair in a spool, and that spool is fitted in the dispensing cartridge in front of the robot, and robot will finally put it to the scalp, right? Long sitting operation when patient has to do it is maybe painful also. It looks very scary over here. Why somebody should go for such an operation where robots are doing something means. It takes time to build confidence when a robot is in front of you instead of a physical doctor, right? And this is yet another interesting application of a robot when a robot is used to do some movie shooting, right? So huge cars that you see flying all around in the air in different movies nowadays, is those cars actually they fly off not just by CGI techniques, it is sometimes very, very physical like this. Two robots are just moving this after an explosion which is simulated here with some sort of sprinklers which was sprayed. This is from a movie which is Fast and Furious done by Universal Studios. This is an amusement task, you see. When robot can make you feel a huge acceleration, right? It can move like anything at different angles, and sometimes the rider also wears a head mount device, that is VR you would say, right? And they just feel the roller coaster. This is demonstrated in one of the fair by KUKA Robotics, and they call it Robo Coaster. It is Robo Coaster when person is made to do all this. Right. So this is again very scary and sometimes risky also. It is not very common though. Yes, but yes, you see now robot can take up all these tasks very easily. So it has a lot of potential to be used even outside the workspaces, no? Not just industrial workspace, it is doing various other tasks. Right. So let us go back to our slide. Yes. So you have just toured to various industrial application and saw industrial robots not just in industry, also outside the industry. So these are some of the examples that you saw. When material handling, it was picking and placing the object from one place to the other, pelletizing, packaging, processing, welding, spot and arc welding you saw, surface finishing you saw, polishing, buffing, grinding, deburring, painting task. Similar is an operation which is called as spray coating, metal cutting you saw using laser gun, gluing, adhesing, sealing, machining, drilling, etc. All these tasks are very, very common in the industry. Assembling needs some special type of robot which is known as cobots. They do normally work with human. Right? It is a collaborative task that needs some sort of compliance also. Machine tending task you saw PCB manufacturing. Not just this, there are many other applications where robot has potential to go. We won't discuss much on them. It is medical, space, underwater, defense, agriculture, movie making and amusement that you saw. Yes, so with this I would end this lecture here. That's all for today. Next class we'll be discussing anatomy of industrial robot, what makes a robot, what all things that goes into making of a robot. Okay, thanks a lot.